The flash butt welding process starts with preparation of the short rails. The rail ends were ground and brushed to remove any corrosion. Batch, mill and heat numbers were recorded. Using a rail schedule, the correct combination of plain and head-hardened rails were selected and sent down the line for welding. At the flash butt unit, the rails were aligned. The specification called for no more than 0.2 mm alignment error measured over 2 meters. Using steel wedges, the welders made sure the rails were correctly positioned. Once set, a small amount of putty was placed on the weld area to act as a lubricant and ensure that the hot weld did not stick to the flash butt welding head. The rail was clamped, and on the operator's signal, the flash butt unit commenced arcing. The flash butt welder passes current across the joint between two rails, arcing or flashing as this happens. This creates heat, and in a short time the rail ends are red hot. The head of the welder pushes these ends together and fuses them. Over the course of 200 seconds, this pulsing intensifies, and at completion, a final large push forces the tacky molten rail ends together. Emerging at more than 1000 degrees Celsius, the rails are sheared of excess steel around the weld area, and still glowing red hot, the weld advances towards the grinding stations. In the case of head-hardened rail, the first process is an air quench that applies chilled dry air to the weld area to reinstate the hardness characteristics of this rail before grinding commences. The grinding process starts with an underfoot grind. This shapes the weld flush with the bottom or foot of the rail, allowing it to seat neatly on the rail pad when installed. Next comes the web grind. Here, the side of the rail joint is smoothed down so that a rail fastening can spring down securely should a weld joint be located directly on an LVT block. Finally, the head of the rail is ground. This is the most critical part of the grinding process. Alignment to within plus 0.2 or minus 0 mm over a 3 metre length must be achieved. With such paper-thin measurements involved, the work becomes as much art as engineering, where the judgment on the look and feel of a finished joint is strongly influenced by the skill an individual welder has with his grinder. Careful sculpting by teams using rotary grinders gradually brings the running surfaces of the rail to a shape that satisfies the exacting tolerances required. The welds and rail strings are numbered as the CWR is created. These unique numbers allow not only for an individual weld to be traced, but also combine with other symbols to create a code indicating the rail type used and a weld's location within the tunnel to an accuracy of 1 metre. Once complete, most rail was immediately hauled into the tunnel and distributed to its required location by a via car over a series of rollers placed on the tunnel floor. With the major components, rail, turnouts and LVT blocks, stored within the tunnel, track construction could commence.